Next is alkene. Okay, the general formula of alkenes is, please pay attention, CnH2n. Now we are going to discuss, we have done the isomerism and the naming of alkenes. Today we are going to see the reactions of alkenes. General formula is CnH2n. Functional group for the alkene is carbon-carbon double bond. We have seen all type of isomerism exists in alkene, including functional group and including cis trans. Okay, all type of isomerism, structural as well as stereo. Now let's look at the preparation of alkenes. How alkenes are prepared. Number one, you remember abhi हमने किया है कि when you crack an alkane, they turn into shorter alkene. So cracking of hydrocarbon or alkane. So you can copy that equation we just did. For example, C6H14 wali to get C2H4 ethene plus let's say C4H10 alkane. Okay. So yes, this is the preparation of alkene by the cracking of long chain alkane. Yeah, alkane ki preparation thi. Number two, from now you have to leave one line empty. From haloalkane, later on we'll see this reaction. We just give a heading and leave a one line because the elimination of haloalkane in the next topic we'll study, and then from alcohols. So these are the three group of compounds which can prepare the alkenes from both these haloalkanes and alcohols by the process of elimination. But I'm not going to tell you these reactions at this moment because in the reactions of haloalkane and alcohols, we'll go through them again, okay? Then I'll tell you, you come back and write the equations for these two reactions over here. Now let's come to the reactions. Alkenes, just like alkane, the first reaction is always combustion. What is a combustion? When ethene with excess of oxygen. Whenever excess of oxygen, an organic compound, including ethene, burn gives us what? And balancing starts with which element? Carbon. So multiply with 2. Hydrogen. Multiply with 2. 2 to 4 or 2 6. Multiply with 3. Okay? And this is called complete combustion. But if the same thing, if limited supply goes, carbon monoxide and water. Okay? So 2CO, 2H2O. Okay? (2O2). Okay? So whenever they undergo the excess, and you remember the general equation for the combustion, for the complete combustion, CXHY plus X plus Y by 4 O2. We had already written this equation in the combustion of alkanes. The same general equation goes here, gives us X CO2 plus Y by 2 H2O. Okay? Next, number 2 reaction. For alkanes, it was, sorry. Yeah, you can also write that equation in which carbon soot along with carbon monoxide is formed, right? But as I told you, that usually happens with the long chain. Okay. Number 2 is addition reaction. X plus Y by 4. Okay, the alkanes were undergoing a substitution reaction, and I defined what was substitution in which the hydrogen of alkane is replaced. Now they undergo addition reaction. Addition is a different, as the name tells you, in which the alkenes add up with another molecule to give one product. Okay, so in addition reaction, if I tell you the principle, look at this. Please pay attention. If this is the addition reaction, please pay attention. In the addition reaction, the alkenes carbon-carbon double bond, bacho, is converted to carbon-carbon single bond actually. And there are 2 valencies which are now free with the carbon. So whatever you are reacting it with carbon, they add up to this molecule. So actually addition reaction may, for example, if I react it with H2, so what happens? Yes, so both these carbons get hydrogen like this. If I react it with Br2, so what is be the product? Both these carbons will have Br. So are you getting my point? The two carbons which are having double bond, the double bond breaks, and the two atoms which you are reacting with, they add up to those carbons, right? So you see, in this case, if I write in general term, A and B react to form one product. See, that's why you call it addition reaction. Two molecules add up to give one product. Okay, this is also that sometimes they also ask you the definition of addition, right? So when two molecules add up to form one product, known as addition reaction. So in order to summarize it, I'm going to write all addition reaction in one go, and you should write it separately. Pere hydrogenation, फिर addition, everything. I am going to write in one go, but I would recommend you कि आप एक go में ना लिखें. For example, look, I'm going to write alkene here. लेकिन आपको मैं कहूँगा आप अलग अलग हेडिंग दें. इधर देखें, ये इथीन है. Listen, parents. Pay attention, everyone. If I react it with H2, hydrogen gas, right? I take a container and ethene gas, mix it with hydrogen, no reaction happens until I add a catalyst. What is that catalyst? Nickel. And what is the heat? We don't write the temperature. Normally it is 100 to 150, but you are not supposed to write the temperature until you don't know them exactly. Otherwise they cross out. So heat is a safe option. Okay? And you heat it. I added ethene and alkene in a container, close it and heat it. Then the double bond breaks and turns into what? Single bond. And both these carbons which are having double bond, they get two hydrogens like this. So you see ethene has turned into what? Ethane. So it's an alkane. So yes, Ilya, you were asking about the preparation. Yes, it is. Okay. So this is how the alkene is prepared. Ethene turns into what? Ethane.
इसका mechanism है. इसका mechanism है hमारे solution से.
Yes, and we'll write it in a while. So this is the first reaction, and the reaction is known as hydrogenation. This reaction is known as hydrogenation. Okay. I'm going to use the same ethene, but you have to give another heading now, which is known as bromination. Okay. Now look at this. If I react this with Br2, but Br2 is not pure, it is dissolved in water or dissolved in CCl4, एक solvent है. तो जब आप उसमें dissolve करेंगे, so what happens? I just told you it's an addition reaction. Double bond breaks, turns into what? Single bond? Yes, दोनों कार्बन पे एक एक क्या अटैच हो जाएगा बच्चों? Bromine. So it will turn into 1,2-dibromo. So it's an alkane. Okay. Oh, sorry, haloalkane. It is known as 1,2-dibromo ethane. Okay. And this reaction, number two type of hydrogenation. They are the type of hydrogenation. Okay. Number one was there are type of addition. Sorry. Number one was hydrogenation. Number two is bromination. Yes, if you can use the chlorine for this reaction, so therefore you can also call it halogenation. Okay, so there is no condition like catalyst and heat. Just Br2 is dissolved in either aqueous or Br2 is dissolved in CCl4. This is an organic solvent. या तो उसमें dissolve करना है या उसमें dissolve करना है. So this is a second type of addition reaction. Please mind it. We are discussing through the types of addition reaction. The first was hydrogenation. The second is bromination. That was addition of hydrogen, and this is addition of bromine. Isi tarah, the third one is addition of, yes, HX. HX mean HCl or HBr or HI, any halogen, hydrogen halide you call it, okay, HBr or HCl, okay, and they are the gases. They are the gases, and you don't need any heat. You don't need. Yes, this is called hydrohalogenation. The third heading there, hydrohalogenation. The third type of addition is hydrohalogenation, yani addition of hydrogen and halogen. Okay, so this is C C H H H H, and what happens here? Here it is H add हो गया और यहाँ कौन add हो गया? Cl. Yes. No, HCl is a gas. So no aqueous, no gas, no heat, nothing. Okay, simple hydrogen halide gas को mix करेंगे alkene से, the reaction starts. And one carbon of the double bond gets H, the other carbon of the double bond gets Cl. So rest of the molecule, if the alkene is even 10 carbon long, rest of the molecule will be unchanged. Okay. Similarly, look at this. This is called hydrohalogenation. And the next one, the last one, is hydration. The fourth type of addition is known as hydration. As the name tells you, it is the addition of water or steam. Okay. So, इसमें जो reagent है, it is HOH, not in the form of liquid, it is in the form of steam. What is the temperature? 350 Celsius. इसमें temperature we have to write. What is the pressure? 60 to 70 atm. And H3PO4 or H2SO4 is the catalyst. They are the catalyst, okay? So it needs a very extreme conditions. Normally alkenes पानी से react नहीं करते. So they need this kind of extreme conditions, okay? And then what happens? Look at this. Yes, one side gets H and one side gets OH. Here is hydrogen and here is OH. So what is this compound formed? Ethanol. And what was this? Sorry, it was chloroethane. Please write the name. So if you look at the functional groups for this to be formed, what are the functional groups to be formed? Pehle mein hydrogenation mein, what was the functional group? Alkane. So please write down so you could have an idea कि alkene से alkane भी बनते हैं by hydrogenation. So this is a method of preparation for alkane as well. Here, this is yes, 1,2-dibromo is also a haloalkane, and you know chloroethane is also a haloalkane. So once we will write the preparation of haloalkane, you know these are the two reactions of alkenes, the addition reaction of alkene, which is going to prepare us the haloalkane. What about this? Ethanol, it's an alcohol. So alkenes are going to be very useful organic compounds because they give us a diverse kind of functional groups to be prepared. So they are very important in organic synthesis, right? So there are 4 types of addition reactions of alkenes, right? Addition of hydrogen, addition of bromine, addition of hydrogen halide, HCl, and finally addition of HOH or steam. So these are all addition reactions of alkene. Now, as we have to discuss the mechanism of one of the type of the reaction of the functional group, जैसे alkane के 3 थे, combustion, substitution, and cracking, and we discussed the mechanism of substitution. Similarly, इसके 4 reactions हैं alkenes के: combustion, addition, oxidation, and polymerization. But the mechanism जो हमने discuss करना है, वो हमने discuss करना है addition का. Okay. Now I'll take one of the reaction from this, and we'll go through the mechanism. Okay. You have to know the mechanism for all of them. Yes, all of them, because they follow the same mechanism. So doing one of them will actually will remain same for all of them, right? So let's start with the bromination se karte hain. Okay, please give a head. No, before I go, sorry, one thing which I tell you, sorry. ये जो हाइड्रोजनेशन है ना, वी लर्नड इन ओ लेवल्स एज वेल, कि जो रिएक्शन ऑफ हाइड्रोजनेशन है ना, इट हैज सम सिग्निफिकेंस इन द इंडस्ट्री, बिकॉज जो वेजिटेबल ऑयल होते हैं ना, वेजिटेबल ऑयल, यू नो, दे आर पॉली एल्कीन्स। पॉली का मतलब होता है मैनी, और एल्कीन का मतलब है डबल बॉन्ड। वेजिटेबल ऑयल्स वो हैं जिनमें बहुत सारे डबल बॉन्ड्स होते हैं। व्हेन यू रिएक्ट देम विद हाइड्रोजन ना, जब आप उनकी हाइड्रोजनेशन करते हैं वेजिटेबल ऑयल्स की, तो दे टर्न इनटू मार्जरीन, वो जिसको घी बोलते हैं आप। सो दिस रिएक्शन हैज अ सिग्निफिकेंस, और ये सॉलिड होता है, ओके। ये वेजिटेबल ऑयल लिक्विड्स होते हैं। तो एक बात ये याद रखनी है कि वेजिटेबल ऑयल्स आर पोली अनसैचुरेटेड कंटेनिंग मैनी डबल बॉन्ड, व्हेन दे आर हाइड्रोजनेटेड with excess of hydrogen in the industry, they turn into margarine, okay, a solid thing that is known as ghee, जिसको हम बुलाते हैं, right, that is known as margarine, ठीक है। और सिमिलरली ये जो ब्रोमीन वाला रिएक्शन है, यू नो, दिस रिएक्शन के नीचे लिख लें, इट इज ऑल्सो टेस्ट फॉर alkene or unsaturation, because you know this has observation. What is the observation? Yes, the orange brown, the red brown color of bromine turns colorless. So this is one of the indication that alkene is present, right? So red brown or orange brown bromine turns colorless. Yes, hence it indicates the presence of alkene or unsaturation. Yes, alkane, if you put the bromine in, the orange brown color of bromine will not change. Alcohol will not change. Aldehyde will not change. Only when there is an alkene, then it changes. Okay, now come to the bromination again. I'll take an example of the bromination. I'll explain how the mechanism, right? For example, look at this. If this is an ethene, bacho, and you reacted with Br2 aqueous, we just learned कि डबल बॉन्ड किस में कन्वर्ट हो जाता है, सिंगल बॉन्ड में, और दोनों कार्बन्स पे what is added? Br. So 1,2-dibromoethane is formed, right? We have to see the mechanism. I always tell you one thing: reaction tells us what happens, and mechanism tells us how it happened. In a reaction is a straightforward thing that is happening. Now listen carefully. Okay, the double bond breaks and turns into what? Look at the other side. Here it was double bond. And what happened? The double bond turns into what? Single bond. Double bond turns into what? Single bond. So what the mechanism tells us, what happened? What happened? The double bond turns into single, and both these carbons have Br now attached. But mechanism will tell us how it all happened. Which bond breaks, where the electrons go. If the bromine is added to the first carbon, the electron pair that is used to attach this bromine, वो कहाँ से आया? ये वाला. The electron pair that is attached to this bromine, वो कहाँ से आया? क्या एक एक कार्बन का है, एक एक ब्रोमीन का है, दोनों ब्रोमीन के हैं, दोनों कार्बन के हैं? Where is that electron pair is gone? This one, the double bond wala. Where is that gone? So this all detail that is hidden behind this thing mechanism. Okay, so let's write the mechanism for this. Okay, in the first step, what happens? So I'm going to write these H open. So just to make sure, just to let you know, there'll be no change in these bonds. Okay. Now, when you mix alkene in a bromine container, first thing happens first, that this bromine and ethene, both are non-polar molecules. Now listen to me carefully. What is the meaning of non-polar molecules? यानी उनमें चार्ज सेपरेशन नहीं है। यानी आपने एक कंटेनर में जब इथीन को मिक्स किया है, with bromine बच्चों, तो both of them are like this. इसका positive negative outside, इसका positive inside or negative outside. This is what the non-polar thing is. So as soon as you mix them, naturally they're going to be the repulsion between the electrons. Non-polar, you know, they always repel each other. And as soon as they repel, the temporary dipoles are induced. So the first thing happens when you mix ethene and bromine, or ethene with any other thing, the temporary dipoles are induced. And when the temporary dipoles are induced, for example, like this is Br positive, this is Br negative, the partial positive, partial negative, the temporary dipoles. The positive side is on the upper side because the ethene has the electrons now. So whenever you write the positive side called electrophile, that should be upward and the nucleophile should be down. But that's the first thing that happens. Secondly, now comes to the mechanism, how the mechanism happened. Now listen carefully. What happens? Please pay attention. One of these two carbons, I assign एक को 1 और एक को 2. Any one, equal option है दोनों के पास. Any one of these carbons now offers pair of electron to bromine to accept it and make a dative bond. कौन सा पेयर? वही पेयर जो थोड़ी देर पहले दोनों कार्बन के बीच डबल बॉन्ड बनाने में इस्तेमाल हो रहा था. रिगार्डलेस ऑफ दिस फैक्ट कि इनमें से एक इलेक्ट्रॉन तो कार्बन नंबर 2 का, एक इलेक्ट्रॉन कार्बन नंबर 1 का है, बट एनी वन ऑफ देम नाउ टेक्स द कंट्रोल ऑफ बोथ इलेक्ट्रॉन एंड ऑफर्स टू द ब्रोमीन. In order to accept that pair from bromine to make a dative bond, bromine को अपना ये वाला पेयर जो है वो देना होगा इसको, यानी हेटेरोलिटिक फिशन होगी. दिस इलेक्ट्रॉन पेयर गोज विद द ब्रोमीन डाउन और ये बन जाएगा Br नेगेटिव. बिकॉज जब भी इलेक्ट्रोनेगेटिविटी डिफरेंस होता है तो इलेक्ट्रोनेगेटिव वो होती है ना हेटेरोलिटिक, एक पॉजिटिव एक नेगेटिव है, राइट. नाउ वन ऑफ द कार्बन एज अ रिजल्ट, वन ऑफ अ कार्बन, नाउ लेट्स सी, मैंने नंबर 2 को असाइन कर लिया, उसने ब्रोमीन को अपने साथ अटैच कर लिया. द अदर कार्बन जिसका इलेक्ट्रॉन छिन गया, नो इलेक्ट्रॉन छिन गया उसका, इट हैज लॉस्ट इलेक्ट्रॉन, it turns the positive charge, so it turns into a carbocation. Just hold on. Carbocation intermediate, just hold on. So what I said, although, listen everyone, although this is the dative bond that is found between carbon and bromine, and both electron pairs belong to what? Carbon, but we don't show it, okay? Organic में बनने वाले हर bond almost dative ही होता है, but we don't show it, okay? Now what happens in the next step? That is the first step, right? I'll finish and then come back, Aisha. So what happens in the second step? This Br negative that comes here, and with its lone pair of electron, ये इसके साथ क्या बना लेगा? Dative bond बना लेगा, okay? So this is C, this is C, H,
Equal arrows we show very happening.
H, right? So this is the Br, and this is the Br. This is the second step.
So those steps are.
Yes. So it's a two-step mechanism. In short, सुनो बच्चा, मैं इसको summarize करता हूँ. मैं simple words में ये कहना चाह रहा हूँ कि apparently what it was looking to us कि दोनों ब्रोमीन एक ही स्टेप में ऐड हो जाते हैं, but actually two steps. So one thing which I told you that it's a simple addition and it takes in how many steps? Two. पहले में एक Br ऐड होता है, दूसरे में दूसरा Br. अब now the second thing I have to tell you कि जो पहला Br ऐड हुआ उसमें इलेक्ट्रॉन पेयर कहां से आया? That was the same electron pair that was used to make a double bond between two carbon atoms. आप कहते हैं ये जो पहला Br ऐड हुआ है, this Br, that was the same electron pair that was used to make a double bond between two carbon atoms. फिर आप कहते हैं दूसरा जो Br ऐड हुआ है, हम कहते हैं वो अपना इलेक्ट्रॉन पेयर खुद लेके आया, that was a nucleophile. पहला वाला इलेक्ट्रोफाइल था, दूसरा वाला न्यूक्लियोफाइल था. So it's a very straightforward reaction कि ये देखें मैंने क्या कहा कि दो Br अटैच हुए हैं. Ilya, what was the first bond that was found between the carbon and bromine? Yes, और वो किसके थे दोनों इलेक्ट्रॉन? और वो कौन से दो इलेक्ट्रॉन थे which was previously used to make? That's a simple bond. कि एल्कीन का जो डबल बॉन्ड था वही यूज हुआ. आप कहते हैं तो दूसरा वो आप कहते हैं अपना इलेक्ट्रॉन लेके आया, पेयर लेके आया, आके उसके साथ डेटे बॉन्ड बनाया, ये वाला। तो आप कहते हैं ये डेटे बॉन्ड कैसे एक्सेप्ट हो गया? आप कहते हैं बिकॉज दैट कार्बन वाज एक्चुअली अ कार्बोकेटाइन, क्योंकि उसका इलेक्ट्रॉन जो छिन गया था, सो दैट वाज अ कार्बोकेटाइन। सो इट्स अ वेरी वेरी सिंपल स्टेप कि आपने एक एल्कीन को लेना है और उसमें पहले एक बी आर ऐड करना है, और जो पहला बी आर ऐड हुआ है दैट वाज अ पॉजिटिवली चार्ज, उसको इलेक्ट्रॉन दिए हैं कार्बन ने, तो दैट वाज एन इलेक्ट्रोफाइल। सो therefore this mechanism is known as electrophilic addition reaction. इलेक्ट्रोफाइल के अटैक से एडिशन हुई है, so we call it electrophilic addition reaction. Okay, electrophile is the one that has a positive charge. Anything that has a positive charge and can accept electron pair is known as electrophile. No, this Br positive that accepted electron pair from the, yes, so that's the electrophilic addition reaction. So in simple words, it's a straightforward. That is a two-step mechanism. In the first step, Br added. उसको ऐड करने के लिए इलेक्ट्रॉन पेयर कहां से आया? The one that was used between double bond between two carbon. फिर आप कहते हैं एज अ रिजल्ट क्या हुआ? एक कार्बोकेटाइन इंटरमीडिएट बन गया. In the second step, what happened? The nucleophile comes in and uses its electron pair to attach with it. For example, अब मैं इसी के आपको दे रहा हूं, इसको कॉपी करें. For example, look at this. CH2, double bond CH2. Just give me 2 more minutes, Aisha. It becomes CH3, CH2, Cl, bacho. We have to write the mechanism for this. We have to write mechanism for this, bacho. Let's write the mechanism for this. I just told you, अब इसमें एक H add होना है, एक Cl add होना है. तो mechanism क्या कहेगा? There will be two steps. In the first step, the electrophile adds, and second step, nucleophile adds. The first step में जो electrophile add होगा, उसको electron pair कौन देगा? वही जो double bond वाला electron pair है, right? So this is simple one. So you write it like this: CH2 double bond CH2. Look at this. और HCl को मैं इस तरह लिख सकता हूँ. Let's say write this. HCl तो पहले से ही आपको पता है ना, इलेक्ट्रोनेगेटिविटी डिफरेंस की वजह से ये इस तरह है. Now कौन पहले ऐड होगा इलिया? Cl और H? H. और इलेक्ट्रॉन पेयर कहां से आएगा? And you can't tell this in words. You have to show a curly arrow from here to here, which shows that the electron pair between two carbon atom is going to use attach hydrogen. अभी होने वाली है. So as soon as ये accept करेगा, ये इधर से break होगा, तभी accept कर लेगा, right? And now what happens? किसके साथ attach करूं? 1 के साथ, 2 के साथ? किसी एक के साथ attach कर सकता हूं. Let's say मैंने 2 के साथ कर दिया, किसी के साथ भी. तो 1 के ऊपर फिर क्या चार्ज आ जाएगा खुबैब? पॉजिटिव. और चार्ज क्यों आया? क्योंकि उसका इलेक्ट्रॉन छीन के उसने नीचे हाइड्रोजन के साथ बॉन्ड बना लिया. ओके, एंड दिस थिंग इज नोन एज व्हाट? कार्बोकैटाइन इंटरमीडिएट.
सर ये सील अपना वो इलेक्ट्रॉन पे लेके जाएगा उस पर.
Yes, now as autolytic fission happened here and chlorine was turned into Cl negative, so this Cl negative now comes here and with its lone pair of electron, वो किसके साथ bond बना लेगा in the second step? Carbocation के साथ. So that's very straightforward. Thank you, sir. It's straightforward, right? So this mechanism is known as electrophilic addition reaction. It's a two-step mechanism in which carbocation intermediate is formed, right? So this is known as electrophilic addition reaction. We'll continue this. We have more information to disclose on this topic yet. So we'll continue this in the next class. Thank you.
Sir,